Alright, let's move on now to cis-diol formation or Syn-Hydroxylation. And what we're looking at is the use of osmium tetroxide and H2O2. And what this does is it adds to the double bond in a cis fashion. So this is all a concerted process right here. All of these bonds are forming at exactly the same time, and trans addition is not possible. So the OSO4 is actually coming in from above the ring and is going to end up joining simultaneously with these two oxygens right here. So let me show you a better picture of that. Alright, so we've got our ring and we've got our double bond right here, and I want you to imagine that the OSO4 is coming in sort of from above, and I'm trying to draw this so it looks flat, so it's coming in and out of the screen. So what happens is this bond goes in here, this bond goes onto the osmium, and this one goes into the space between the O and the C, or if you like you can draw that arrow to the C. So just kind of drawing this a little bit more flat. You can now see how the OSO4 adds to the double bond, but adds from above and adds in a cis fashion. Now, had this not been happening concertedly, all at the same time, one might think that it might be possible to get some rotation going here, and you might be able to get some sort of different kind of addition, but really what's going to happen is that this is going to add in a cis fashion. In the next step, what's going to happen is that the mannitol and the NaHSO3 is going to cut these bonds right here, and we're going to end up with a cis alcohol as a product. The effect of the mannitol and the NaHSO3 is that they are reducing agents, and all they're doing is taking the OS bonds here and converting that to an OH bond and breaking that apart. What that also gives us is OSO2. The purpose of the H2O2 in the reaction is to regenerate OSO4. So the OSO2 gets oxidized by the H2O2 back to OSO4, which can go ahead and react again with another molecule of alkene. So we only need a catalytic amount of this in the reaction mixture because it keeps on getting regenerated. That's a good thing because this thing is extremely poisonous and we want to be using as little of that as we absolutely possibly can. You'll notice if we go back to the PowerPoint here that what I've done is I've put two products here, but I've put an OR here. Now the reason for that is because this is cis, I can actually flip this over like a pancake and I could get the same thing. So if I put an OR here, what I'm saying is I can either show it like this or show it like this, but they are the same thing. That's in contrast to the previous one with the bromine, where I got two different products that were enantiomers, and that was because the mirror images were not superimposable. This one here would have superimposable mirror images, so I could only put down one product for this particular reaction.